Throughout my time as a biology student at Elmhurst University, I've developed not only scientific knowledge, but a greater understanding about how science connects to ethics, collaboration, diversity, and society. My coursework, labs, and research projects have helped prepare me for my future goals of becoming a pharmacist. Throughout my biology coursework at Elmhurst, I learned that biological problems often require concepts from multiple STEM disciplines. Many biological processes cannot be explained by biology alone. For example, when studying the cardiovascular system, there were concepts from anatomy, physiology, chemistry, and physics all working together to understand how oxygen transport, blood flow, and pressure regulation work together. One real issue I studied was environmental racism in my environmental ethics course. This problem cannot be solved by biology alone because it involves also sociology, public policy, environmental science, economics, and ethics. While biological research can identify health effects caused by pollution exposure, solving the issue requires lawmakers, healthcare professionals, environmental scientists, and even community workers working together. I learned that solving large biological problems requires collaboration between both STEM and non-STEM disciplines. Scientists and healthcare workers contribute research and medical knowledge. I specifically learned this when I was writing a paper for my physiology class about wood frogs being able to be frozen for long periods of time with the use of cryoprotectant. Through this, scientists can test different technologies for possible ways to store organs and possibly preserve them for longer periods of time. Another interdisciplinary skill I developed was learning how to communicate scientific information clearly to people outside of biology. Through the use of presentations, group projects, research papers, and even lab write-ups, I was able to explain biological and chemistry concepts to classmates or other majors that in a way that people would be able to understand. Overall, my experience at Elmhurst taught me that biology is deeply interconnected with many other disciplines. Scientific problems are rarely isolated, and effective solutions require collaboration, communication, and perspective from multiple different fields. Biology is deeply rooted and connected to ethics, society, politics, culture, and public understanding. My coursework helped me critically analyze how science affects people and how outside influences can shape scientific research. One ethical issue connected to anatomy and biological research is the testing, treatments, and medication on the human body. Scientific advancements in medicine require clinical research, but these must follow strict guidelines to protect human subjects. Through my coursework, I learned the importance of informed consent, safety, and oversight of ethics committees and institutional review boards. We looked at many different case studies from my anatomy class that helped us understand these regulations. An example of an unethical animal testing that stood out to me was an experiment involving the elephant named Tusco, which we talked about this in my physiology class, who was injected with an extremely large dose of LSD in the 1960s, and that experiment resulted in the death of the animal and raised serious concerns about animal welfare and scientific responsibility. Cases like these demonstrate how scientific research in the past sometimes prioritize experiments over ethical treatments of these animals. Learning about experiments like this helped me understand why modern scientific research now requires a stricter ethical oversight, especially regarding animal testing. Today, a lot of research institutions must follow different regulations designed to minimize the suffering and justify the necessity of animal use in their experiments. I also learned that scientists' backgrounds and perspectives can influence research questions and their interpretations. Science becomes stronger when diverse perspectives are included because those researchers from different backgrounds can recognize problems or impacts that others can overlook. Those diverse representations in science improves innovation, healthcare equity, and the quality of that research. My biology education also taught me how science directly impacts society on both local and global levels. Biological research influences medicine, environmental policy, agriculture, public health, and technological advancements. A legal implication I learned about involved regulations surrounding human and animal research. Institutional review boards and federal guidelines exist to ensure that researchers protect participants and follow those ethical standards. These legal requirements help maintain safety and scientific integrity. During my lab courses and group projects at Elmhurst, I worked with students who had different approaches to problems based on their experiences and academic strengths. For instance, this would be in my organic chemistry class where we would be put with lab partners. In my lab group, we would attack problems in different ways that we would think of, and it would often work in better ways than we thought. So those different perspectives often led to different ideas or interpretations that I didn't consider before. When writing research papers, I also learned that using diverse sources and considering how biological issues affected different populations can strengthen scientific understanding. For instance, my environmental racism project showed me how certain populations can experience unequal health impacts. Throughout my biology coursework, I learned how important communication is in science. In presentation, lab reports, and group projects, I practiced explaining scientific concepts to different audiences, including classmates, professors, and people outside of the biology field. I learned that scientists must communicate clearly and accurately so scientific information can be understood and applied effectively. Many of my courses involved collaborative lab work and group projects where many students brought different strengths and perspectives. Working with these teammates taught me how to establish shared goals, divide responsibilities, and adapt to different working styles. Another important skill I developed was learning how to give and receive constructive feedback. In lab courses and research assignments, peers reviewed and improved the quality of my work and encouraged scientific accountability. I learned how to critique ideas respectfully while remaining open and revising my own work based on evidence and feedback. Overall, my coursework at Elmhurst taught me that science is not only about technical knowledge, but also about communication, collaboration, reflection, and the ability to work effectively with people from diverse backgrounds and disciplines.